Okay, so this one is limit of a sequence. Let L be a real number. Let f be a function of a real variable such that the limit of the function as x approaches infinity is the real number L. If a sub n, this is our notation for a sequence, such that f of n is equal to a sub n for every positive integer n, then the limit of the sequence itself is equal to L. So let's look at this problem here. The limit of a sub n, which is given by 1 over n squared plus 3n plus 2, is equal to, well, we need to find a function f of x so that for every f of n, the value is equal to a to the n, a sub n. So our real valued function could be x squared plus 3x plus 2. If we get the limit of this, and we found the limit is L, then that will be the same limit of our sequence. Okay, so for our function, let us consider f of x is equal to 1 over x squared plus 3x plus 2. If we evaluate a sub n at 1, then we're gonna get 1 over 1 squared plus 3 times 1 plus 2, and that should give us 1 over 1 plus 3 is 4 plus 2 is 6. At the same time, if we evaluate f of x sub 1, we should get 1 over 1 squared plus 3 times 1 plus 2, which should also be equal to 1/6. So this looks like a possible function. Now, how do we find the limit of this function as x approaches infinity? Well, what we will do is multiply this by 1 over x squared, 1 over x squared. That is equal to 1. Okay? So what happens now is this. If we divide both numerator and denominator by x squared, we will get 1 over x squared. This will give me 1, 3 over x plus 2 over x squared. This will give us 0. This is also 0. And so our limit is 0. Therefore, the limit of the sequence is 0.